Okay, so this will be the last video for this week. I'm just going to do a few examples from section 11.3. So I'm going to start with guided practice question number 1 from the textbook. So that's over on the left-hand side right now. It says the perimeter of triangle ABC is 16 feet and its area is 64 feet. So I try to draw that out on the right side. So triangle ABC is the one on the left. We know its perimeter is 16 feet, its area is 64. Then the perimeter of triangle DEF is 12 feet. Then it tells us these two triangles are similar to each other. So find the ratio of the area of triangle ABC to triangle DEF, and then find the actual area of triangle DEF. All right. Um, so we don't have any sides, but we do have both perimeters. We know the perimeters and the sides have the same ratio. So I'm going to start with that. So the ratio of perimeters is going to be 16 to 12. Okay, and that can be simplified a little bit, right? Could reduce both of those by 4, so 4 to 3. So that's the same thing as the ratio to sides. Sides and perimeters are both going to be 4 to 3. All right, so the first question is find the ratio of the areas. We know that if we take the ratio for the perimeters and we square it, that would be the ratio of the areas, right? So 4 squared is 16, and then on the bottom 3 squared would be 9. So perimeter ratio of areas is 16 to 9. Okay. The last question, or last part of the question, says to find the area of triangle DEF. So now I want to set up a proportion. Since I'm finding an area, I'm going to use the areas ratio. If I was finding a side or a perimeter, I would use 4 over 3. But since I'm finding an area, I'm going to use 16 over 9. So 16 over 9 equals, and then I know the area from the larger triangle, it's 64. They told us that, so that would go right there. And then the area from the smaller ones, what I'm trying to find, so that's going to be x. So we're going to cross multiply, so 16 times x is 16x. 64 times 9 is 576. I'm going to divide that by 16. And so that comes out to be 36. All right, so 36 would be our area for that smaller triangle. All right, so that's it for that one. Now we're going to look at example 3. And they turned into a word problem about baking pans, not super important. We're just going to look at these rectangles right here. And we're going to just solve for where the question mark is. So they basically want to figure out how long is that side on the right of the smaller rectangle. All right, at the bottom, they gave us both of the areas. So I know, dang it, the ratio of areas is going to be 150 to 96. Okay, and then I want the ratio of the sides because I'm trying to find a side. So what I need to do is square root the ratio of the areas. Now, we had to do this earlier in the year, and if you don't remember, sometimes they'll just give you numbers that are perfect squares that are easy to square root right off the bat. That didn't happen this time. When it doesn't happen, you want to try to reduce it. And if you reduce it, usually you can reduce it to something that will be perfect squares, and that's usually a faster way to do it. So these can both be divided by 6. If I divide by 6, then it's going to be 25 over 16, and those are both numbers that I can square root very easily, right? So now it's 5 to 4, right? And so 5 to 4 would be my sides ratio. Okay, now that I know the sides ratio, I can set up a proportion to find out what the question mark side is going to be. So I would do 5 over 4 equals, then the side that corresponds with the question mark is 10 inches on the larger rectangle. So I'm going to put a 10 across from the 5 because those both come from the bigger triangle. And then, the question mark is right there. We can just call that x. Right, so cross multiply again. 10 times 4 is 40. That's going to equal 5 times x. Divide that by 5. And so that side would be 8 inches in that problem. Okay. let's take a look at one final one. So I should have probably gone over this in the last video, but I forgot. So in the book, there's this little paragraph at the top of this page on regular polygons, and it just basically says any two regular polygons of the same type are always going to be similar. So if you have two regular pentagons, they'll be similar. Two regular triangles will be similar. Two regular octagons will be similar, right? So any two regular polygons that have the same number of sides are always going to be similar. So sometimes instead of telling you that two shapes are similar, they might just tell you like, oh, they're both regular octagons. And in that case, you should know from this paragraph that that means they have to be similar. The last sentence in that also says any two circles are always similar to each other as well. Okay, so then last thing we'll take a look at, this guided practice question number 2. It says the ratio of the areas of two regular decagons is 20 to 36. So again, they didn't say they were similar, but because they're both regular decagons, they have to be similar, right? And the ratio of their areas is 20 to 36. It says what's the ratio of their corresponding side lengths in simplest radical form. So if I'm starting with areas and I want to go to sides, I need to square root. Again, these aren't perfect squares. Well, 36 is, but I'm going to reduce it. I could divide, let's see, probably just by 4. So it turns into 5 over 9. I want to square root that. So that's really square root of 5 over square root of 9. You could take the square root of 9 on the bottom. You're going to leave the top as a radical. And so the ratio of the side lengths would be radical 5 to 3. All right, that is all for this video.